Hard drive anatomy involves platters, read-write heads, tracks, sectors, cylinders, and clusters, or allocation units. Inside the sealed case of the hard drive lie one or more platters. The platters are where the actual data is stored by the read-write heads, mounted on a mechanism that moves them in tandem across both surfaces of all platters. Older drives would have used the stepper motor to position the heads at discrete points along the surface, which had spun at thousands of revolutions per minute on a spindle mounted to a hub. Newer drives use voice coils for more analog movement, resulting in reduced data loss because the circuitry can sense where the data is located through a servo scheme, even if the data shifts due to changes in physical disk geometry. Before a hard drive can store data, it must be prepared. Factory preparation for newer drives or low-level formatting in the field for legacy drives maps the inherent flaws of the platter so that the drive controllers know not to place data in these compromised locations. Additionally, this phase creates concentric rings, also known as tracks, which are drawn magnetically around the surface of the platters. Sectors are then delineated within each of the tracks. These are the magnetic domains that represent the smallest units of storage on the platters. And then within the sectors, the magnetic drives can commonly store only 512 bytes, half a kilobyte of data each. And then you have cylinders and you have clusters, allocation units. The capacity is a function of the number of sectors it contains. The controller knows exactly how sectors are to be laid out within the disk assembly. And then the directions are for the basic input-output system, which does not always understand the actual geometry. For example, you may not support more than 63 sectors per track. Nevertheless, almost all hard drives today have tracks that contain many more than 63 sectors per track. As a result, translations must occur from where the basic input-output system believes it is directing information to where it's actually to be written. So here we see that the drive is to be formatted within a file system after initial preparation by the operating system, and then it's ready to store data. File systems lay down the tracks of their sectors, routinely group a configurable number of sectors into equal or larger sets called clusters or allocation units. These clusters exist because operating system designers have to settle on a finite number of addressable units of storage and a fixed number of bits to address them uniquely. No two files are allowed to occupy the same sector, so the opportunity exists for wasted space if small files occupy only part of a sector. Clusters exacerbate the problem by having a similar. The operating system does not allow any two files to occupy the same cluster. Thus, the larger the cluster size, the larger the potential waste. So although you can increase the cluster size generally to as low as 64 kilobytes, which corresponds to 128 sectors, you should keep in mind that unless you are storing a notable number of very large files, the waste will escalate astoundingly, perhaps negating or reversing your perceived storage capacity increase. And